Hey folks, it's Mr. Ray here with our next calculus lesson. We're going to be doing the quotient rule today. Uh, so if you remember the last couple lessons we did, we started off with polynomial, basically the rule to differentiate polynomials. Then we looked at the chain rule, which was for composite functions. And the last lesson we did was product rule. And if you remember, there was one example we did for product rule where it was actually a quotient of, it was like a rational expression, and we turned it into the product rule question by just moving the denominator up to the top, flipping the exponent. So what we're going to do today is learn the quotient rule. There's going to be times when will use the quotient rule and times where you'll do the flip and do the product rule, but I'll talk more about that a little bit later, okay? So we'll just start off with the actual rule. If you have a rational function h of x, which is composed of division f of x divided by g of x, then the derivative of h of x is the derivative of f times the g function minus f function times the derivative of g all over the g of x function squared, okay? So if you look at the top, it looks a lot like, well, it looks similar to the product rule. We had the same order. The only difference was we had a plus sign here, okay? And that's a good point because I talked in the product rule lesson that it didn't really matter which order you put these two things because it was a plus for the product rule. But for the quotient rule, you do have to remember that it's f, the derivative of f times g minus f times the derivative of g. You can't do the other way around. So, and of course that's all over this. So I remember when I was learning this myself, and I was given the option whether, do I want to do this quotient rule or do I want to do the product rule? And the product rule, when you look at it, it looks a lot simpler and a lot easier to do. Now, the benefit of doing quotient rule is in the simplifying stage. If you remember that question we did in the last lesson, we had to do, a couple of steps of simplifying just to get a common denominator. And when you do the quotient rule, as I learned later, it's sometimes very advantageous to just go ahead and do the quotient rule. The first step seems more difficult, but the simplifying makes it worthwhile to do the quotient rule. So, and if you don't simplify the result, you will lose marks, okay, because part of it is simplifying. And that's kind of what it says here. You could leave the function in fraction form and use this rule, or you could express the function as a product and use the product and power of a function rule. So that's basically what I was just saying. Here's the Leibniz notation. Hopefully you're getting used to what that means. It still looks a little bit different than this, but hopefully you're starting to see that. So let's do some examples. This is going to be a pretty short lesson. We've only got 3 examples. So we have this h of x function that's a rational function, 3x minus 4 over x squared plus 5. So we're going to do the quotient rule, just leave it as a quotient. Okay, so always remember it's the derivative of the numerator function. So that's derivative of 3x minus 4 is 3. And that's multiplied with the bottom function. And then we subtract the derivative of the denominator function, the bottom function, so that's 2x, and the original f of x function on the top. Now it doesn't matter which order you do these two things. I know I didn't really go by the order they said here. I did the derivative of these g of x first. The order you multiply doesn't matter, but the order you subtract does matter. So no big deal if you switch the order between the two multiplications. Okay, and then the bottom is going to be x squared plus 5 squared. Okay, now we don't have to expand that. We can always leave it like that. Okay, so no matter what the exponent, if it's a rational exponent, we want to change that to, you know, a radical sign. It probably won't be negative, otherwise it would have been on the top to begin with. So now we just simplify the top. So we've got 3x squared plus 15 minus 6x squared, and that's going to be plus 8x. Okay, and now we've got got the bottom we've got to fill in here. And then one final step, just to combine the like terms on the top, we've got a negative 3x squared plus 8x plus 15 all over x squared plus 5 squared. Okay, and that is as simplified as you want to get. Okay, so that would get full marks doing it that way. So if you try doing this using the product rule, you'd see that the first step is quite easy, but then you get a couple of different expressions with different denominators. You've got to come up with a common denominator. I think one of the denominators would be x squared plus 5, and the other one would be x squared plus 5 squared. So there's a lot more work to do if you do product rule. So give it a try yourself. If you think, well, I'd like to try product rule, sometimes you learn best by just trying it yourself. Don't take my word for it. Well, don't always take my word for it, but try it yourself, and you'll see like I learned myself, hopefully. Okay, another question here. Determine the equation of the tangent to y equals 2x over x squared plus 1 at the point x equals 0. Okay, so you see equation of the tangent. Tangent means derivative. So the first thing we're going to do is find the derivative of y. So that's going to be dy by dx. And again, this is a quotient. So we'll do quotient rule. We've got a derivative of the top. So it's a 2 times the bottom function. And then subtract derivative of the bottom times the top function. They both happen to be the same. And then the bottom is the bottom function squared, x squared plus 1 all squared. Expand the top. You get 2x squared plus 2 minus 4x squared over x squared plus 1 squared. And then we can just combine the 2x squared terms. We get a minus 2x squared plus 2 over x squared plus 1 squared. So that's really what you're looking for there. Now they want the equation of the tangent at that point. So we have to know. So we know x is equal to 0. So usually when we ask for the equation of a tangent, we need the x and the y coordinates of that point. So to get the y coordinate, we just plug in x equals 0. Now make sure you plug it into the original equation, not the derivative. So you plug in a 0 there, that's 0 over 1. So y is equal to 0. So we're looking at the point 0, 0. Okay, so we're going to take this derivative. We're going to plug in our x equals 0. So dy by dx for x equals 0, I'll just put that in there, is equal to, and now we're going to go negative 2, 0 squared plus 2 over 2 squared plus 1 squared. Oh, what am I doing? 2 there. That should be 0. Okay, so at the top, we get 0. That's a 0 times Negative 2, that's still 0, plus 2. So we get a 2 on the top, we get a 0. Yeah, put a bracket there. 0 plus 1, 1 squared is 1. So that's going to be equal to 2. So that tells us that the slope of the tangent is 2 at this point. So I can immediately go, well, I'll call that m now. So the equation of the tangent is going to be y equals 2x plus b. And when we plug in our point 0, 0, we get 0 equals 2, 0 plus b, and that's obviously makes b equals 0. So the equation of the tangent, we just put our b value back in there, which is 0, is y equals 2x. Okay, and that's it. So hopefully you should be getting good at these find the equation of the tangent questions. All we're doing is practicing using different types of derivative rules. Okay, last question here. This one's a little bit trickier. Determine the coordinates of each point on the graph f of x equals 2x plus 8 over root x, where the tangent is horizontal. And that basically means slope of the tangent equals 0. Okay, horizontal tangents mean that's a 0 slope. Okay, so the first thing we're going to do is find f prime of x using the quotient rule. So that's the derivative of the top, 2x plus 8, that's going to be 2 times the bottom function, so 2 root x, and then this one's a little trickier, it's going to be minus. Now that's going to be, you probably remember the derivative of the square root is going to be 1 over 2 root x. I won't do all the steps. We've done this before. It's 1/2 x to the negative half, and x to the negative half means it's 1 over square root of x. Okay, so that's the derivative of the bottom times the top function. That's 2x plus 8 all over, and this one works out quite nicely, square root of x squared, and that's going to turn into just x. Okay, so we got some simplifying, expanding to do there. 2 root x minus, I'm just going to put the 2x plus 8 on the top, and have a 2 root x on the bottom, and that's going to be all over x, because square root of x squared is just x. Okay, now you can do some simplifying here. We can divide everything here by 2, the 2x, the 8, and the 2 root x, and we're just going to get, I'll do that part first, okay? So that's going to be x plus 4 over root x. That's just dividing everything by 2. And then if I want to turn this into something over root x so that I could combine these two terms, that means I got to multiply the top by root x. So 2 times root x, well, that's just 2x. Okay, and then x on the bottom, of course. Excuse me. And then we're going to have, if you just read across the top, I'm going to have 2x minus x, so that's x, and then minus 4, don't forget you're subtracting the 4, so that's going to simplify to x minus 4 over root x times x, sorry, not times, over x, and let's do one more step here. So if I turn this into, so that would be x minus 4 over root x, and then multiply by the reciprocal of this, so 1 over x. So we get That's going to be equal to x minus 4 over x root x. Okay, so there's our derivative function for f. Okay, we've got to find the coordinates where the tangent is horizontal. So basically we take this equation and with the tangent, we're going to use the fact that the slope of the tangent is 0, so that's your f prime of x. So that's going to be 0 is equal to x minus 4. I'll just leave it with the x for now, just so you know where this came from. X root x. And now if we go back to, well, actually no, we don't know what x is. That's what we're trying to solve for. So if I get an equation like this, you may remember this from advanced functions. If you have equation like this equal to 0, well, that just means the top is equal to 0. So 0 equals x minus 4, so therefore x equals 4. So that's your x coordinate. It means there's only one point that has a horizontal tangent. And if you plug in x equals 4, so that's going to be 2 times 4 plus 8 over root 4. So that's 8, 16 over 2. That's going to be equal to 8. Okay, so that tells you, therefore, the point on the graph where the tangent is horizontal. I could say 0, but I'm kind of going back with the wording of the question, is the point 4, 8. Okay, so that was just 3 practice questions how to do the quotient rule. Each of them asking slightly different thing. The first one was just find the derivative function. Next one was find the equation of the tangent where the slope of the tangent was a certain value. And then the last one, find the point on the graph where the tangent is horizontal. Okay, so that's all there is to this lesson. A few questions you can practice. But again, I'd like to recommend if you're given a rational function and has to do the derivative, I think it's a better choice to use quotient rule rather to turn it into a product and then do product rule. Okay, so that's it for today. We have one more lesson. I'll have it for you Thursday around noon probably, or maybe in the morning, and that'll be for something called second derivatives. And just to let you know what a second derivative is, it's when you take the derivative of the derivative. So it's like a double derivative. Okay? All right, guys, have a great night. Talk to you later.